I just want to use this video to discuss a few examples and mainly on the concept of probability density function, or more commonly known as PDF. And let's look at this first one. Let's use the idea of PDF and to find the value of A. It's pretty straightforward actually. When we talk about PDF, we really talk about the area under the graph, and sometimes it could be asking you to count from here to here, or sometimes from here to here. And anyhow, in this case, the total area, actually whether for this one or this one, is 1. The total area 100% or 1. So we just need to form the area formula. This is a triangle. Clearly you can see that the height is 0.5, and this is the width, or rather the length of base. So that will be half times A times 0.5, and because the value will be equal to 1, the total area is a concept of PDF. So the 0.5 is really half, and by equating this to 1, you find A equals to 4. So this is how you use the concept of PDF to calculate unknowns like this. Look at another examples right here. This is a trapezium like this. Height of this trapezium, say the length of base is 40 units, and apparently this is actually symmetrical. In this case you can see this. So to find the area, we just let this, we think like this, form two triangle. So really we just need to find this triangle and times 2, so I get the area of here, and together with here, that will be times 2. So I do that first. Okay, the area of two triangles will be 10 times A times 2, right? Because there are 2 of them. So it will be half times A and times 10. So this will be an area of one triangle because there are 2 of them, and it's symmetrical in this shape. So this will be times 2. And area of this rectangle, I think, yeah, should be a rectangle with 20, difference here 20, and the height is A, so 20A. So therefore, the sum of this expression and this expression will be 1, because this is a PDF, and as we know, the area under curve is 1. The whole total area here should be 1. So the sum of this, which is here, plus the sum of this, the rectangle, is 1. And if you simplify this, you will get 30A on the left side equal to 1. And so is, this is 30. So A is equal to 1 over 30. We look at one more example, longer examples to wrap up the introduction on the concept of PDF. So for these examples, I'm not going to do all, but just some of the key parts. First, part A, I will leave it to you because you really actually have the answer. Your job is to show that A is equal to 1 over 45. All you need to do is to find the area of this, and the area of this, and the area of this, and the sum of the 3 areas, or no matter how you're going to do this, is equal to 1, and there you can find the value of A. You should practice that. And then calculate the probability that x, when x equals to 0. Now, it means they ask you to find px equals to 0. This is a PDF which for a continuous distribution. The idea is that because we're really in estimating the ideal value, like the idea of height, your height is 1.6 meters. It's not really exactly 1.6 meters, depending on the measuring tool that you use to measure height. It could be 1.6 point more, to be 1.60001 meter, or even smaller, or no difference. So the idea of x equals to 0 it really is meaningless here. So therefore, the probability of x equals to 0 implies that, well, there's only one explanation one way to say this is actually 0. And similarly, with this concept, probability that x equals to 10 is also 0. Okay, as for part 3, the probability for x between 0 and 10. Now this makes sense because we are talking about an interval for a PDF. That makes a lot of sense. And in other words, translate to probability like this. They ask you to find probability when x lies between 0 and 10. Now, the idea of this is really about area under curve, and 0 and 10, so we're talking about the area extending from here to 10 and under this red line segment. So we're really talking about area under curve this. From part A, we know what the value of A is. The value of A should be 1 over 45. In other words, the area of this, if you think carefully, the area of this trapezium is the answer. So employing the formula of a trapezium, that would be this, the sum of the length of this base and this, the parallel sides. That would be half A plus 3A, and times the height of the trapezium, that would be 10. And since, so that would be 5, because this would be simplified to 5, and times 4A. But we know what the value of A is. You're supposed to show that A is equal to 1 over 45. That's the task in part A. So you end up seeing this 1 over 45 times 45, and you should actually get 4 over 9. Okay, and I leave part 4, 5 to you here. And from 10 to 22, you think about how to settle this. This is actually a line that is parallel to the x-axis. And the idea of x greater than 25, think about this. This is really where 20 and A, and this is 30 and 2A. And remember that A is 1 over 45. The answers I put here. And lastly, this one part, I will do part 1, and suppose you should do part 2, I'll leave you the answer. They ask you the value of k for which the area under curve is equal to 2 over 3. Well, let's recall that the area here, if you calculate properly, is 4 over 9. And that is equivalent to well, roughly 44%, right, from 0 to 10. And then here it said, well, so you can sure that k is somewhere more than 10, but could it be after 20 or before 20? And so we probably recall that also the area of 10 to somewhere to 22 is 61 over 2 to 5. That the answer given to you. And this is roughly 27.1%. So in other words, 2 over 3 is 67% approximately. 67%, 0.67. And so therefore we can expect that the k value of k, or rather k, lies somewhere around here, and we don't know where it is, but we expect it somewhere here, k. So let's try and use the idea. It means that if that is the case, k could be here or here, and when we want to then add this area and this area of the rectangle, the height is a, or 1 over 45. We found that in part A. And the length of base will be k minus 10. It makes sense? because the triangle, the rectangle could be this size. So the 2 or 3 is right here, and this probability of x less than k now translated into idea of area, something like this. 4 or 9, the area of the trapezium from 0 to 10, and it's 1 over 45 is the height of this rectangle, and k minus 10 is really the length of this base. We do not know where it is, so we put k minus 10. If you simplify this, you will be able to find that k is equal to 20. So that means that really we are talking about the area of here until x equals to 20, or k is actually really 20. And the answer for part 2 is k equals to 15. I'll leave it to you, and I hope you get the idea of PDF, and perhaps you can try more problems.